Before watching this video, I recommend that you make sure you're familiar with the very first Math Antics video that covers inequalities. It does a great introduction to it, so that's the grade 8 video. If you're in grade 9, or if you're interested in pushing the envelope and pushing your understanding a little bit, then take a look at the grade 9 video. It goes a little bit more in depth, but it does push into a little more complex algebra. Let's just do a quick refresh on what inequality looks like on a number line. When x equals 1, we do a solid dot. For x greater than 1 or less than 1, we do a hollow dot with an arrow either to the right or the left, depending on whether it's greater than or less than. So here we've got x greater than 1. We do a hollow dot with an arrow to the right. When we've got greater than or equals, then we do a solid dot because it includes the equals, and with the arrow again to the right. We've learned in the past that when we have an equation like negative x equals 4, if we multiply both sides by negative 1 to solve for x, we find that x is equal to negative 4. If we look at that on a number line, what that means is that when we plot negative x equals 4, we're really plotting x equals negative 4, which means we put a dot right on negative 4. So let's dig a little bit deeper and see exactly why that's true. Suppose we had something like negative x is equal to 3. Well, it might actually help the understanding a little bit better if we put some brackets in here so that the x is separate from the negative sign. So negative of something, x, is equal to 3. So the question is, what is that x? What goes inside those brackets? Well, the first thing to note is that in front of the 3, we understand there's a positive sign there. It's a positive 3. But out front here, we've got a negative. So we've got a negative of something that is x, and that's going to give us a positive number on the other side. Well, in order to have a positive number over here, that means we have to have a negative number in this space. So whatever number we're putting in place of x has to be a negative number, because we've got a negative out front already. So to end up with a positive on the other side, whatever we put in for x also has to be negative. So that means negative of some negative number is going to give us a positive on the other side. So from that, we can conclude that that x has to be a negative number. And if it has to be a negative number, well, obviously we want to end up with 3. So x has to be negative 3. So if negative x equals 3, that means x is equal to negative 3. Put a solid dot on the number line at negative 3. Now let's see what happens when we work with an inequality. Suppose we had negative x is greater than 3. Again, using the brackets to help us out here, because remember, we want to know what x is equal to, not what negative x is equal to. So I'm going to put in those brackets so that we separate out the x from the minus sign that's in front of it. We know that there's a plus sign implied in front of that 3, right? It's a positive number. And over here, if we're going to subtract something and end up with a positive number, that means the thing that we're subtracting has to be a negative. Let's take an example. Supposing we put negative 4 in there for x, and we've got a negative sign out in front of that, so we're subtracting a negative 4, which will give us a positive 4. And that, of course, is greater than 3. And you can probably see that if we kept going with smaller and smaller numbers, so negative 5, for example, we're subtracting a negative 5, that turns into a positive 5, which, of course, is still greater than 3. However, if we had negative 2, then negative 2 turns into a positive 2, which, of course, is not greater than 3. And of course, negative 3, when we put it in, would give us a positive 3, which of course is not greater than 3. It's equal to 3. So that one doesn't meet the requirement for this initial inequality either. So what we can see here is that we do a hollow circle at negative 3 because negative 3 doesn't make the inequality true. But all the numbers to the left keep that inequality true. And if we look at what those numbers are, they're all the numbers that are smaller than negative 3. So that means that x has to be less than negative 3 to be true. Remember, we started with an equation that said negative x was greater than 3. You can see now, to keep the equation true, if we multiply both sides by negative 1, we have to flip the inequality symbol that's in between them. Let's check this out and make sure that this all makes sense. If we have an inequality that says 5 is less than 7, we know that's true. If we multiply both sides by negative 1, we'd end up with negative 5 is less than negative 7. If we look at a number line, negative 5 is here, and negative 7 is there. If we're going to the left, that means these numbers are smaller over here. So that means that negative 7 is smaller than negative 5. In order to make that statement true, we have to flip the inequality. So negative 5 is actually greater than negative 7. So as we saw in an earlier example, if we had something like negative x is greater than 4, if we multiply both sides by negative 1, we end up with x is less than negative 4 because we had to flip the sign. When we have an inequality, if we multiply by negative 1, we need to reverse or flip the inequality sign to keep the inequality true. If negative x is greater than 5, then x has to be less than negative 5.